Hey everyone, I'm Luca. I'm a researcher, and that's why my slides might look a little bit different from the usual slides. I'm a technical person, and I'm here to talk about Ethereum's roadmap to 10 million TPS. And in the DeFi world, we usually got used to ask ourselves when we see those super high yield values. We used to ask ourselves, where does the yield come from, right? And in the world of high TPS chains, you should ask a similar question to yourself, which is, where does the scaling come from? Because in the same way that for very high yields, there's probably something fishy going on. You're probably the yield, right? For these very high TPS chains, it is likely that they are compromising something. So it's very important to know when you use these chains, where does the scaling come from. And one of the Ethereum's core value that we want to preserve compared to other projects, other blockchains, is that we want to maintain the property that users should be able to independently verify their property rights with no trusted intermediaries. So what we mean by this is we want users to be able to run blockchain nodes. We want users to be able to run their transactions on their own hardware. And this hardware has to be cheap, has to be, we don't want this to be very expensive. We don't want to be having terabytes of RAM machines to be able to verify the tokens that you're holding and whether the state that you're touching is correct. So it's really important for us for users to be able not to depend on any intermediary, to know that your tokens are there. And of course, if you want to have this property, the bottleneck is you need to have a blockchain that goes at the speed of this lowest node that you want to support, right? Ideally, we would want to have users running their full node on their smartphone, or maybe on a smartwatch, right? And these computers are very slow, hence you might want to rate limit the speed of your blockchains to be that slow. And this is what Ethereum has been doing. If you look at past performance, Ethereum has been doing like 12 TPS. Right now it's doing around 20 TPS, which is pretty bad, right? But this is because we want to preserve this value. We want users to be able to run nodes. The thing is that there is some new tech that allows to allow nodes to be able to verify things that are much more powerful than them. We call this an execution verification asymmetry. And there is new cryptography that allows this. There are fraud proofs and there are ZK proofs. ZK proofs seems to be more promising than fraud proofs. But the idea here is a node, instead of having to re-execute all the transactions to know that the state is correct, they can just verify a ZK proof, which is this cryptographic proof, right? But the problem is the tech is nowhere close to be mature enough to be used for Ethereum. This is new tech. This is experimental. It hasn't been on production for a very long time, so right now we cannot use it for Ethereum, to scale Ethereum. So the short-term solution that we found is, OK, let projects that are willing to take such risk experiment and iterate. And that's why we got to rollups, or L2s. So what L2s do is they use ZK proofs to scale their computation. They have much higher throughputs than Ethereum, but they produce the ZK proof, which is this very small cryptographic proof that they send to Ethereum. And these proofs are much cheaper to verify than the execution that they cover. And right now, Ethereum is doing, if counting the rollups, is doing around 300 TPS, and which is, again, much better than what Ethereum is doing today at 20, but it's still not 10 million, as I promised. The thing is, the ZK technology is getting more mature with time. It's getting faster. And the Ethereum Foundation and Ethereum in general has committed to bring the ZK technology on Ethereum itself. There is new initiative for real-time proving. There is a website showing the stats on the progress towards being able to ZK-prove L1 directly. We need some more performance improvements to make it viable, to make it fast enough, but this is happening. Like very soon, maybe in 1 year, maybe in 2 years, we'll be able to use the ZK technology on Ethereum itself and make use of this asymmetry for scaling. The thing is, why is it the case that with this technology, rollups are only doing 300 TPS? And the limit here is in data availability. So the way that these rollups work, I'm not going into the details, but they need to post their transactions on Ethereum to be able to inherit the security properties like ordering, consensus, and censorship resistance, right? But the thing is that the data throughput that Ethereum supports only allows for 300 TPS max. The good news is, on the 3rd of December of this year, there will be a new upgrade for Ethereum, which introduces blob sharding. This is, again, a new cryptographic primitive that allows to scale how much data throughput the blockchain can support while still keeping verification low. So potentially, we'll be able to support very, very high throughputs, and nodes will be able to verify that all this data is available just by downloading a very small part, but with the same guarantees as if they were downloading everything. And this is, again, new tech. I don't have time to go into the details. But this is called blob sharding. And 1 week later, this upgrade, Ethereum already bumps the data throughput limit to be able to support 500 TPS. And 1 week later, again, there will be another bump to be able to support 800 TPS. So from 350 that we have today to around 800. But the target for this upgrade, so if everything goes well, if we see that the networks reacts well, the idea here is to bump the DA throughput limit to be able to support almost 4,000 TPS. So we're kind of getting there, right? The thing is, if you look at other blockchains that are also working on DA, and one, of course, wonderful example is Celestia. They're doing an amazing job in scaling data availability. In the next upgrade, which will happen soon, they will already be able to scale data availability to support 120,000 TPS. And this is, just to give you an idea of what is possible to support with data sharding. And their long-term goal is to reach 1 gigabyte per second of data throughput that rollups can use, right? And if you do the math, this is a simple linear function of how many transactions per second this can support. You get to around 5 to 6 million TPS, which is a very good number, right? The thing is, with all these new cryptographic innovations, we kind of solved the verification bottleneck. So as I said before, right now, today, Ethereum is slow because we are bottlenecked by the speed of re-executing all the transactions, by the speed of verification. With this new tech that unlocks the execution verification asymmetry, we solved the verification bottleneck, and now the bottleneck is on the execution side, how fast we can produce blocks. And if you look at modern blockchains, it is believed that the serial execution performance limit for a single blockchain is around 10,000 TPS, right? Maybe there is one order of uncertainty for this value. Maybe it's 10,000 TPS, or maybe it's 100 TPS, but still, this is not 10 million, as I promised initially, right? So if one single blockchain can only do maximum, let's say, 10,000 TPS, how we can get to 10 million TPS? And the simple idea here is you can have multiple blockchains that run in parallel, right? So instead of having just one blockchain that does 10,000 TPS, you can have multiple ones in the same way that Ethereum today has L2s and rollups like Arbitrum, Base, Linea, ZK-Sync. And all of those will be building blocks in parallel. They will not be limited by each other's speed. And all of them will be publishing transaction data to Ethereum. There have been many criticisms around L2s and rollups because There is this stages column on this website. This is a website from L2Bit. I work at L2Bit. I spent a lot of time looking at these projects. And what stages are is basically an indication of how decentralized those systems are. If you're stage 0, you're fully centralized, which is bad. If you're stage 2, you're fully decentralized, which is good. If you're stage 1, you're kind of in the middle. And if you look at all the top L2s, all the top rollups, none of them is stage 2, which is kind of bad, right? Because we want to be super decentralized, but none of those systems are. And we need to understand why. And one thing that I'm also working on these days is native rollups. And what are native rollups? So the idea here is all these projects need to be centralized because ZK proofs, as I said before, is experimental. And they want to have multisigs, they want to have security councils to protect from bugs. This is one reason, and the other reason is they want to be able to upgrade to maintain feature parity with Ethereum. If Ethereum introduces a new feature, they also want to upgrade to have this feature, so they need to have some, again, multisig security council that can upgrade, which is, again, a risk of centralization risk. But here, the idea is, if we implement native rollups on Ethereum, they will be able to reuse the same ZK verification infrastructure that Ethereum already uses. They don't need to deploy their own stuff, and they don't need to maintain their own stuff. And if they reuse what Ethereum already uses, if Ethereum upgrades, they would also upgrade automatically. So the idea here is no dedicated proof system. You can use the same ZK stack already used by L1. If there is no dedicated proof system, there's no need for security councils. You automatically upgrade with L1, but still you can support custom sequencing. For example, you can have centralized sequencing with super fast pre-confirmations, like 200 milliseconds pre-confirmations that projects really like. You can have custom gas tokens. For example, you can support a chain. You're able to deploy a chain that has a yield-bearing stablecoin as a gas token. You can capture all the fees yourself. And you can easily opt in or opt out of this feature of being native. So the TLDR of native rollups is, you can see native rollups as customizable Ethereum shards or Ethereum copies with full potential Ethereum security. And here I say potential because, of course, you can customize these chains and you can customize them in ways that can lower their security. But potentially, they can be as secure as Ethereum. So the TLDR, how to get to 10 million TPS in 3 simple steps is, first, you get data availability, or like data throughputs, which we also call blobs, limit to 10 million TPS. And again, this is feasible. Data sharding scales amazingly well. Then you push the single chain limit, the single execution environment limit to 10,000 TPS. And then you get 1,000 of these chains doing 10,000 TPS each for a total of 10 million TPS total. And the coolest part of all of this is that all these chains, all these 10 million TPS are fully verifiable on a very light machine. You can potentially verify all of these throughputs, all of these state changes on your smartwatch or on your phone, right? So this is kind of the unlock that the new technology, this new cryptographic technology allows, and what differentiates Ethereum from the other blockchains. That's the end of my talk. Thank you.